You imagine you are sending a text or images. The data travels as a long string zeros and ones. Uh, in bad network connection, the data can be flipped. It can 0 to 1. This is called 1-bit error. Uh, in that uh, in that error detection using parity checking. In this discussion, we are discuss about what is the parity checking, what types of error we are using, and we are discuss about it.
Now I am going to talk about the single bit error. Single bit error is a flip concept of 0 to 1 and 1 to 0. For example, in a computer there is a flip bit which can change the command save to delete. So if I send 110 and it receives 111, it is a last bit error which is a single bit error.
Going to explain about burst error. So when the consecutive bits are corrupted in data transmission, then it is known as burst error. Let's take an example of spilling a tea on a paper. When you try to spill a tea on a paper, it will spread throughout the paper. It will not split with a particular area. So it will causes the consecutive error. So that is also called as burst error. So let's we take a real-time example of taking when we try to watch a movie in Netflix. Our devices are connected through same Wi-Fi. So it will cause an error, consecutive bits of errors are connected means our video starts to buffer. So it is a type of error, which is a burst error. Then another example is when you try to call your friend through a phone call, the signals get corrupted, then you get a buffer noise. Then it is also a type of consecutive error, which is called as burst error. So there are multiple errors when you try to open a folder in like a text folder or a image folder. Then it shows it is corrupted, sorry, then it is also a type of burst error. So these are the real-time examples of burst error in our daily lives.
In parity checking, it has two types. First one is the even parity and odd parity. Raghavi, explain what is even parity.
So even parity is of making the count of ones is an even number. So for example, if you take even parity as a basis one, we get ones in our message. If there is an odd number of ones in our message, we get to add one at the last, so it becomes an even pair. So if it is already paired up, we just add 0 at the end, so it will be of 4 ones or 6 ones or 8 ones. So here the receiver acts as a bouncer. If the coming number of ones is an even, it gets passed through the data. If it is an odd number of pairing, it won't get passed through the data. So for example, if the number is 1011, it is of number of ones is 3. So we'll add 1 at the last and it becomes 4 ones. So it gets even.
Previously, we explained what is odd parity.
Odd parity is the error deduction technique. So that where the extra bit is added to the data, so that total number of ones is must be odd. Let's take the real-time example. Every groups has the leader. Stay alone. It is the odd number, so that do nothing. So add 0 at the end of the data. If it is even, add 1 at the end. Let's take another example. Consider the binary number 1010. It is total number of ones is 2. So we can add the 1 at the end. So it becomes the odd. At the receiver side, the count will be calculated again, so that it is the odd. The data is correct. If it is even, it is error is occupied in the data.
Earlier you tell about what is the limitations in parity checking.
So first of all, parity means there are two types: odd parity and even parity. In every parity, we were able to check only one bit, so it is one of the major drawback in this case. So to check more than one bits, like multiple bits or 2 bits, we can use CRC. Also, it is only used to detect, it may not correct any errors in the data word. So it is one of the major drawback in this parity check. CRC will be able to find 2 errors or multiple errors. Also, it cannot correct the errors also. one of the technique which is used for correcting the errors will be the Hamming code. In Hamming code, we give parities and data. First, we find the parity and add it to the data word, and finally, after calculating the detection side, we can also correct the data which is being an error in which bit. So it will be useful for finding and correcting the error also. So parity bit has bit can able to correct only one error. Meanwhile, Hamming code maybe it will be useful for correcting many errors and able to find in which bit the error has occurred also.
In this conclusion, thank you students for sharing your ideas for parity checking for case study reviews.
Thank you.